to section 8.6. So we're on page 589. And we are talking now about solving rational equations. And the thing that you need to focus on today is this right here. These are equations. The method that I'm going to show you for solving these today can only be done with equations. It cannot be done with expressions, which is what we worked with in the last section. Okay? So in the last section, we saw things like 2 over x plus 5 over x minus 1. And in order to put those together, what do we have to do? Get a common denominator. This doesn't factor. What's our common denominator going to be? X times x minus 1. Good. We need both of those in there to make them both happy. So this becomes 2 times x minus 1 over x times x minus 1 plus 5x over x times x minus 1. Because here the x minus 1 was new, so we have to put it on the top. Here the x was new, so we have to put it on the top as well as the bottom. That's 2 times x minus 1 plus 5x over x times x minus 1. And we had to go to all of this effort to get a common denominator and then put all this stuff together. Why? Because this was an expression. And that's what we got as our answer. Everybody okay with that? Now what we're going to do is we're going to have the same problem, but now it's going to be equal to something. Okay? And so now, for example, maybe you have something like this. And we're not going to go all the way through this example, but we'll at least get it started. Maybe this thing is equal to 3. What makes this different than the last one is right here. This makes all the difference in the world, guys. And I cannot stress that enough. The mistake that a bunch of you are going to make is you're going to try and apply this method that I'm going to show you today to the problem like I just erased, where there was no equal sign, and you're going to get it wrong 100% of the time because you're going to do something that you're not allowed to do. Okay? The way that you are going to approach these is different. It's going to start the same. You need to find the lowest common denominator. So what is our lowest common denominator going to be? X times x minus 1 still, right? This one didn't change anything. It's just 1x times x minus 1. So what we're going to do now, though, is different than what we did a moment ago. Instead of changing all the denominators, what I'm going to do is I am actually going to multiply this equation on both sides by x times x minus 1, the lowest common denominator. Notice, I said I'm going to multiply this equation on both sides by the lowest common denominator. Why was I not allowed to do that here? There were no sides. There was only one side. Right? If I take a number, a fraction like a half, and I multiply it by 100, is it still equal to the same thing? No, 50 is clearly not equal to a half. I've changed the value of it. But because of the equal sign, I'm allowed to multiply both sides of the equation by the same number, in this case x times x minus 1, without changing the value of my variable. That's what makes these different, is we have an equal sign. Therefore, there's a left side of the equal sign, and there's a right side of the equal sign. And as long as I do it to both sides the same way, it's not going to change my answer. What it's going to do is this. First of all, whatever you multiply by, put it over 1, so that you keep your numerator and denominator straight. When I multiply here, what's going to happen to the x's? They're going to cancel out. This is going to cancel out this, leaving me a 2 and an x minus 1. What's in the denominator? after these cancel out? Just 1. Do I need the over 1? No. Do you guys see what I accomplished by doing that? I got rid of the denominator completely. When I distribute this here, what's going to cancel out? The x minus 1's leaving us 5 times x over 1, but do I need the over 1? No. Equals, on this side, nothing cancels. I have a 3, an x, and an x minus 1. Do you guys see that by multiplying by the common denominator, the lowest common denominator, I have killed off all my fractions? And what allowed us to do that? Come on, all together now. What allowed us to do that? The equal sign. That's the key. Without that equal sign, you can't use this method. If you try to, you're going to get the wrong answer 100% of the time. So you cannot use this for adding and subtracting. You can use this for solving when there's an equal sign with a left side and a right side. Is everybody clear on that? Write yourself a big giant note in your notes about that so that you remember that when you guys are doing these problems. If you try and apply this process to last night's or the previous night's problems, you're going to get the wrong answer every time. Now what we would do is we would distribute, and we get 2x minus 2 plus 5x equals 3x squared minus 3x. And now notice I have x squareds and x's, so I'm going to have to collect everything on one side. And what this is eventually going to give you is 0 equals 3x squared minus 10x plus 2. What would you now do to try and solve this? What would you use? Either factoring, or if it doesn't factor, what would you use? Quadratic. This one actually won't factor, unfortunately, guys, so this one is going to be the quadratic formula. We're not going to finish this one out right now. I just wanted to show you the setup so that you understand the concept that we're getting at here. Okay, I didn't pick the numbers so they would work out nicely. So this one you would finish with the quadratic. Will that happen from time to time? Sure. So I suppose we could finish this out. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's 10 plus or minus the square root of 100 minus 24 is 76 over 6. That's 10 plus or minus the square root of 76. That breaks down into 2 times 38, which is 2 and 19. So what can I pull out of there? There are 2, so this is 2 square root of 19 over 6. Can I simplify anything? Yeah, 2 goes, remember, it has to go into all 3 of those or you can't cancel it all. And so this is going to be 5 plus or minus the square root of 19 over 3. Questions about that? So that's how you would finish it if you need to use the quadratic formula. Again, I didn't really intend for us to finish that one out all the way. I just wanted to talk about the setup, but there was no reason why we couldn't. Now, there is one more step to doing these, which I'll talk about on the next example. Okay, but does everybody understand the concept behind what we're working with here? The way we solve these equations is we find the common denominator, but we don't change our denominators. We multiply everything on both sides to clear the denominators out so we don't have to worry about them. All right, let's look at another example. 3 over x plus 1 is equal to 9 over 4x plus 5. Now, what the book tells you to do typically, and what most people will do on this, is they will cross multiply here. Are we allowed to cross multiply here? Yeah. Fraction equal to a fraction, you can absolutely cross multiply. I don't want you guys to cross multiply though. Cross multiplying can become very dangerous on these problems. Because remember what we talked about with the last section. It's not any common denominator that we want to use. Any common denominator will work, but the one we really want to use is what? The least common denominator. Why? Do you remember what I said? What's that? Well, but any common denominator will get rid of the fractions. Do you remember what I said? Why we don't want to use? Yeah, but specifically why? Yes. but specifically. Right. Lower powers of x by using the least common denominator. We won't have extra x's floating around. And what's the danger with extra x's floating around? Remember what I said? Where does that cause a problem in our whole process? The factoring part. Remember that? It's a lot easier to factor x squared plus something or x cubed plus something than it is to factor x to the 5th or x to the 6th or x to the 7th. So by throwing extra stuff in there, you may make your life impossible or certainly a lot more difficult in terms of the factoring to finish solving the problem. So we really need to use the lowest common denominator. The problem is that when we cross multiply, we're not necessarily using the lowest common denominator. We might be, but we might not be. If those two denominators have something in common, then we're throwing extra stuff into the bag that we don't need, and we're making our lives more complicated. So what we're going to do is we're going to find our lowest common denominator. Does this factor? That's all one piece. Does this factor? All one piece. So what's going to go into my lowest common denominator then? X plus 1, 4x plus 5. And so what we're going to do is we're going to multiply this side by x plus 1, 4x plus 5. Don't forget to put it over 1, guys, because otherwise people will multiply top and bottom by that, and then they'll get themselves lost. Remember, it's a 1 on the bottom. We're going to multiply this side by x plus 1 and 4x plus 5 over 1. Here, do you guys see that the x plus 1's cancel, and we get 3 times 4x plus 5? Here, do you see that these cancel and I get 9 times x plus 1? Everybody see that? Now, take a look. What would we have gotten if we had cross-multiplied? Yeah, this way we'd get this, right? And this way we'd get this. So do you see that we could have cross-multiplied here? But if those two denominators had something in common, we would not get the same answer by cross-multiplying. We would get a much more complicated answer by cross-multiplying, and that's what we're trying to avoid. So if you do these all the same way and not do the cross-multiplying stuff, your life will be easier. Okay, now what do we do? Distribute. 12x plus 15 is equal to 9x plus 9. Subtract 9x from both sides. We don't have any x squared, so we don't have to worry about factoring. I'm also going to subtract 15 from both sides at the same time. And we get 3x is equal to negative 6, which makes x equal to negative 2. Now, very important, guys, and I didn't talk about it on the last one. I mentioned it after the fact. But we are not done. Why are we not done? Well, yeah, you have to check it, because the problem is that this is the solution to this equation. But was this the equation we were told to solve? No. The equation that we were told to solve was this equation. And this equation had denominators in it. And what do we have to worry about anytime we're dealing with denominators? Yeah, what happens if those denominators are equal to 0, one or both of them? It's extraneous, right? Exactly, we get extraneous solutions. We can't divide by 0. So we have to check at the very least, even if you don't check to make sure the numbers match, which you should do anyway, but at the very least you've got to check to make sure that the x equals negative 2, or whatever answer or answers you get, does not make any of the denominators 0 in the original problem when you plug it back in. If it does, it's extraneous, you need to throw it out. And if there are no answers left after you're done doing that, then what do you put? No solution. Does x equals negative 2 make this denominator 0? No. Does it make this denominator 0? No. So we're okay. There's our answer. Now, to check the actual numbers, it would give us 3 over negative 1, which is negative 3. And it would give us 9 over negative 8 plus 5 is negative 3. 9 over negative 3 is also negative 3. It does work. But at the very least, you must check for extraneous solutions, because quite often you will have to throw one or more of your answers out. Any questions about that idea? So do not forget to check them. For example, what would have happened if this was x equals negative 1? Well, that would have made this denominator 0, and we would get an undefined value equal to some number. You can't have a non-number equal to a number. You can't have a non-number equal to anything, even another non-number. If it's not a number, it can't be equal. Everybody clear on that concept? Okay? And this is why it's so important that you guys understand why you can't divide by 0. Do you see how many times it's popped up this year? It's popped up in solving equations. It's popped up in finding vertical asymptotes. It's popped up over and over, which is why at the beginning of the year I wanted you to understand exactly why we were not allowed to divide by 0. All right. Questions on that one? Let's look at another one. How about 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. First thing we need to do, we've got to find the LCD. In order to do that, we've got to factor our denominators. Does this one factor? Does this one factor? Into? Make sure you factor it so that you can find what to put in the bag. This one doesn't factor. What's going to go in the bag? Good. So we're not going to change the denominators. We're going to kill them off by multiplying both sides by x plus 3, x minus 3 over 1, x plus 3, x minus 3 over 1. Don't forget the over 1. Here, those cancel, and we just get 6 times x plus 3. Here, what cancels? Both of them, right? So we just get 8x squared from the top, minus here what cancels? Yeah, the x plus 3's, and so we get a 4x times x minus 3. Does everybody see that? Now we can distribute. 6x plus 18 is equal to 8x squared minus 4x squared plus 12x. Remember, we're distributing the negative along with the 4x. So 6x plus 18 equals 4x squared plus 12x. Notice we have x squareds and x's. We're going to want to factor this, which means we need a 0. So subtract this and subtract this. Those are gone. We get our 0. 4x squared plus 6x minus 18. The first thing I would do here, guys, is I would divide everything by 2. We're allowed to do that because of the equal sign. 0 equals 2x squared plus 3x minus 9. Why did I do that? Because it shrinks my numbers down. It makes the factoring easier. Now we know this is going to be 2x and x if it factors. This is going to be 3 and 3. This is going to be plus. This is going to be minus. That gives us plus 6x minus 3x, which is plus 3x in the middle. There's our negative 9. There's our 2x squared. So if I set these equal to 0, what is x going to be? So x is equal to 3 over 2. And x plus 3 equals 0 gives us what? So we have x equals 3 over 2 and negative 3, and we're done, right? No, what do we have to do? Check it. Plug it back into the original. Does 3 over 2 make this denominator 0? How about this one? How about this one? How about this one? No. So this one's good. Does negative 3 make this denominator 0? How about this one? As soon as it makes the denominator 0, you've got to toss it out. It's extraneous. Which means our only answer is 3 over 2. Does everyone see how that works?
When you're finding the least common denominator, do you also find it as the back?
All the denominators. Yeah, you're looking at all the denominators on both sides. Because we want to kill all the fractions off on both sides. If we just look on one side or one fraction, all we're going to kill off is that particular one. We're not going to kill off the rest of them. We want to get rid of them all at once. Does that make sense? Other questions, guys? Does everybody think they have a grasp on this? Does anybody feel like they need to see another example, or do you get the idea? Everyone's good? Awesome. Okay, in that case, I will give you the homework assignment.